We have already explained that the Moon's orbit around the Earth was created by the Earth's rotating gravitational field. If no other external forces were acting on it, the Moon's orbit around the Earth would have to be circular. We call this circular orbit the base orbit. Due to the influence of the Sun's gravitational field, the shape of the Moon's orbit deviates from its original circular path. When the Moon is outside the Earth's orbit around the Sun, the Moon's orbital speed around the Sun is slower than that of the Earth. As a result, the Moon moves away from the Earth in quadrant 1 and moves closer to it again in quadrant 2. The Moon's orbit outside the Earth's orbit around the Sun could be as shown in the diagram. When the Moon is on the inside of the Earth's orbit around the Sun, the Moon's orbital speed around the Sun is greater than that of the Earth. This causes the Moon to move away from the Earth in quadrant 3 and move closer to it again in quadrant 4. The Moon's orbit within the Earth's orbit around the Sun could be as shown in the diagram. Then the Moon's orbit would have to be an ellipse, as shown in the diagram, and its center would have to be the center of the Earth. This is obviously not the actual orbit of the Moon. We have also explained that every moving mass has an inertial force that directly and significantly influences its motion. The Moon's orbit can be thought of as consisting of two movements, a circular movement around the Earth and a radial linear movement. The effect of the inertial force on the circular movement is that it limits the Moon's rotational speed to its orbital speed and does not increase it further by driving the Earth's gravitational field. Let us now look at how inertial force acts in a radial movement. Let us assume that the Moon is at position 3 as its starting point, which is the point furthest from the Earth. At this point, its centrifugal force of rotation around the Earth is less than the gravitational force of the Earth, so it approaches the Earth due to the gravitational force of the Earth. At this point, the speed of the Moon around the Sun is also less than that of the Earth, so the Moon also moves toward the Earth. These two effects cause the Moon to move radially toward the Earth. When the Moon reaches the position of point 5, the Earth's gravitational pull is equal to the centrifugal force, and the speeds of the Earth and Moon around the Sun are equal. This means that the two forces that cause the Moon to move toward the Earth are zero. However, the Moon's radial motion continues due to its own inertial force. When the Moon enters its base orbit, its centrifugal force is greater than the Earth's gravitational force, and the Moon's speed around the Sun is greater than that of the Earth. The effect of these two forces is that the Moon is pushed outward. Since these two forces are initially smaller than the Moon's inertia and cannot stop the Moon's movement, the Moon's inertia only drops to 0 at point 7, and its radial movement speed returns to 0. The principle of movement from point 7 and then to the position of point 3 is exactly the same as that from point 3 to point 7, only in the opposite direction. This is the mechanical principle of the Moon's orbit. Obviously, the shape of this lunar orbit is not elliptical, as previously believed. For detailed explanations, see the link below.